एक आपका आवाज एक मिनट
विशाल जी, your voice is
विशाल जी,
cracking.
नेटवर्क का प्रॉब्लम है क्या? कुछ नेटवर्क का प्रॉब्लम है तो हेमंत जी है अपने साथ, हेमंत जी को तब तक ले दीजिए। आपका नेटवर्क सही होगा तो फिर आप जुड़ जाइएगा। हेमंत जी अपने साथ है तो हेमंत जी को लेने दीजिए स्टार्टिंग में, बाद में आप आ जाइएगा। ठीक है, हाँ हेमंत जी का नेटवर्क सही है तो उनको लेने दीजिए स्टार्टिंग में, बाद में आपका नेटवर्क सही होगा तो आप भी जुड़ जाइएगा। हाँ मनु जी, कितने बजे स्टार्ट करने का?
सर लाइव स्टार्ट कीजिए, लाइव का लिंक दे दीजिएगा। मैं वाइस प्रिंसिपल नूतन मिश्रा जी से रिक्वेस्ट करता हूँ सर, मैं आपको
अभी मैं लाइव एक मिनट में लाइव स्ट्रीमिंग देखता हूँ, उसके बाद
ठीक है, लाइव स्टार्ट होगा तो हम लोग स्टार्ट कर देंगे सर।
लाइव स्टार्ट हो गया है, स्टार्ट कीजिए।
Good afternoon one to all present here. I, Dr. Abhimanyu Mishra, would like to welcome Honorable Director of Mount Carmel Group of Schools, that is respected Parveen Singh sir, Chairman venerated Rupali Singh ma'am, Vice Principal Mr. Nutan Mishra, and Ravi Shankar ji, who is founder of IDYM Group of Company and scientist of ISRO. Tinu Lasmi, CEO of IDYM Group of Company. Mr. Vishal Kahar, Chief Collaborating Officer. I would like to request our Director Sir to give permission to start the show.
Okay, thank you so much, Hemant ji. Now I request Engineer Hemant Mehta ji to please proceed. Hemant ji, please proceed.
रवि जी एक मिनट, अगर हमारे डायरेक्टर सर यहाँ पर मौजूद हैं, मैं उनसे परमिशन देता हूँ कि आप सर परमिशन दें शो को स्टार्ट करने के लिए। डायरेक्टर सर परवीन सिंह सर।
ओके सर, प्रोसीड।
थैंक यू सर।
स्टार्ट कीजिए।
हेमंत जी, you are requested to lead the show.
उनका नेटवर्क प्रॉब्लम। विशाल जी तब तक इंट्रोडक्शन दीजिए ना। विशाल जी, हेलो विशाल जी, कैन यू हियर मी? विशाल कहर जी, कैन यू हियर मी? विशाल कहर?
Yes, I can hear you.
Please, yes, please go ahead.
Okay, so I will start sharing my screen now. I mean presentation. Wait a minute.
Please do that, please.
Okay, so here it is. It is taking a bit. Okay. Let me know if it's visible. Visible, eh?
Yes.
Okay, great. So students, before we start, I would like to tell you all a few things. See, first thing कि हमको ये इंटरेक्शन वाला बनाना है, ठीक है? हमको बस सुनते नहीं रहना है, आपको जवाब भी देना है बीच में, राइट? तो इसके साथ we will begin our space exploration program for today. So first thing, before talking about anything space, पहले तो ये चीज मेरे को जानना है कि how many people of you have dream of going to space? आप में से कितने बच्चे स्पेस में जाना चाहते थे या जाना चाहते हैं? किसी को नहीं जाना स्पेस में?
Me sir. Students, please answer the question.
Yes sir, I want to go space.
Yes sir. क्यों जाना चाहते हो? Why do you want to go to space?
Sir, I want to explore what's the thing wandering in space, about planets, dwarf planets, and about distances.
Okay, that's great. See, this is why we are going to talk about it. Like space में हम सब जाना तो चाहते हैं, but why is it important for us to go to space and why is it important to explore it? So हम कितनों को मालूम है कि when did India launch its first satellite? Does anyone know that? No one. So हमने पहला हमारा जो रॉकेट लॉन्च किया था इट वाज इन 1969, अभी से अराउंड 60-70 इयर्स पहले, राइट? 60 इयर्स पहले हमने हमारा पहला सैटेलाइट लॉन्च किया था। अभी like now we have started talking about why when India started going to space, but पता है इसका importance क्या है? When India went to space, Dr. Sarabhai had one thing in mind कि a lot of countries like USA, China, Russia, they were all sending their satellites into space, and Russia was the first to launch a satellite in space. It was the Sputnik missile, Sputnik satellite. So what happened is when Russia went to space, America thought that it is going to be a danger to America. Okay, क्योंकि अगर स्पेस में हम सैटेलाइट भेज दिया, राइट, अगर उसके अंदर कैमरा होगा तो हमको ये भी पता चलेगा कि विच काइंड ऑफ मिसाइल यूएसए इज यूजिंग और वहां पे क्या क्या चल रहा है। वी कुड सी एवरीथिंग दैट इज गोइंग ऑन हियर ऑन अर्थ फ्रॉम स्पेस। तो इसके वजह से जॉन एफ कैनेडी ने उस टाइम पे बोला कि लाइक नाउ द चैलेंज इज दैट वी विल send humans to moon and get them back alive within 10 years। एंड इसके बाद अपोलो 11 हुआ, नील आर्मस्ट्रॉन्ग पहुंचे मून पे, बज एल्ड्रिन पहुंचे, एंड द रेस्ट इज हिस्ट्री, राइट? उसके बाद जो स्पेस रेस चालू हुआ, देयर वी सॉ कि लाइक ह्यूमंस मून पे जाने लगे। वी हैड मिशंस टू मार्स, वी हैड मिशंस टू जुपिटर, सैटर्न, इवन सन पे भी अभी मिशन हो चुके हैं कई सारे। लाइक एक मिशन अभी लॉन्च किया था अमेरिका ने विच वाज सोलर पार्कर प्रोब, राइट? तो वो अभी सन के नियर बाई वो रिवॉल्व कर रहा है, ऑर्बिट कर रहा है। सो नाउ द थिंग इज कि हम ये सब क्यों कर रहे हैं? व्हाई डू वी हैव टू स्पेंड सो मच मनी ऑन दिस थिंग? लाइक अभी जो एक जेम्स वेब टेलीस्कोप गया, कितनों को जेम्स वेब टेलीस्कोप का नाम मालूम है? किसी को नहीं मालूम? हेलो, हेलो, एनीवन? आई गेस किसी ने नहीं सुना। सुना है नाम जेम्स वेब टेलीस्कोप? ओके, सो राइट नाउ जेम्स वेब टेलीस्कोप हमने जो लॉन्च किया, जो हबल टेलीस्कोप के बाद वाला हमारा दूसरा स्पेस टेलीस्कोप है, उसका कॉस्ट हुआ है $20 बिलियन, राइट? $20 बिलियन। तो $20 बिलियन में कितने जीरो आते हैं ये हम खुद अंदाजा लगा सकते हैं कि 1000 मिलियन होता है तब जाके 1 बिलियन होता है। सो वी कैन अंडरस्टैंड कि इतना पैसा खर्च करने का क्या मतलब इफ यू हैव टू लॉन्च अ सैटेलाइट। सो द थिंग इज कि ये सब यूज करके हमको ये पता चलता है कि हाउ डिड वी कम इनटू एग्जिस्टेंस, right? How did earth come into existence? How did sun come into existence? हमारा प्लेनेट यहाँ पे ऑर्बिट कैसे कर रहा है वो हमको मालूम पड़ा। हाउ मच टाइम डू वी हैव ऑन अर्थ ये हमको मालूम पड़ेगा कि लाइक अर्थ थोड़े टाइम में घूमना बंद कर देगा या ठंडा पड़ जाएगा या ग्लोबल वार्मिंग हो रहा है तो क्यों हो रहा है। सो ऑल ऑफ दिस आर आंसर्ड बिकॉज ऑफ दिस स्पेस टेक्नोलॉजी, ये सैटेलाइट से सब लॉन्च करने से। एंड दैट इज व्हाई इट इज वेरी इंपॉर्टेंट टू बी इन स्पेस। और अभी तो देखो सिर्फ नॉट जस्ट स्पेस एक्सप्लोरेशन इज फॉर फाइंडिंग आंसर्स फॉर अर्थ, but it is also important because it plays an important role in defense। अभी 99 की वॉर थी कारगिल की, जिसमें हमने ऑपरेशन विजय किया था, जिसमें कैप्टन विक्रम बत्रा थे, कैप्टन मेजर सौरभ कालिया थे, ये सब थे, राइट। तो ये सब करने का मतलब क्या है? व्हाई वाज इट इम्पोर्टेंट फॉर अस टू बी इन स्पेस इन 1999? नाउ द थिंग इज कि हम सबने गूगल मैप तो यूज किया होगा, कितनों ने किया है गूगल मैप, और कितने मेरे को बता सकते हैं कि हाउ डज इट वर्क, गूगल मैप कैसे काम करता है?
Sir, I have
It's
listened
not.
about, I mean,
क्या यूज किया है, राइट? तो कैसे काम करता है?
sir, we have to point out locations over in the Google Maps about an area or where we have to go by pointing out the distances and
राइट, पर वो काम
location.
कैसे करता है? नाउ दिस इज यू आर टेलिंग मी कि उसमें करना क्या होता
Sir,
है, ऐप कैसे काम करता है, आई एम नॉट
sir,
आस्किंग यू दैट।
I think that Google Maps uses machine learning in combination with various data, sir, with
नो,
historical
इट
events
यूजेस
and
सैटेलाइट इमेजिंग,
yes,
सैटेलाइट
sir, satellite
नेविगेशन यूज करता है, राइट।
and sir,
सो
receive
सी,
notifications.
yes, so now see, the
Sir,
thing is when
also I think
you are
I think predictive lights, sir.
huh. So see, this is why space is not just useful for exploration of other planets, but it is also important for day to डे एक्टिविटीज। जैसे कि गूगल मैप जो है वो जीपीएस सैटेलाइट्स के नेटवर्क से बना है, राइट। सो वैसे ही इंडिया का खुद का भी एक प्लेटफॉर्म अभी आ रहा है, जिसको हम बोलते हैं नेविक, जो इंडियन सैटेलाइट्स में यूज होगा, इंडियन आर्म फोर्सेस यूज करेंगे, पुलिस यूज करेगी। तो लाइक सी, अभी नेविक का काम क्या है? सो जब 99 की वॉर हुई, अमेरिका हैड जीपीएस सैटेलाइट्स इन ऑर्बिट, राइट। अमेरिका के पास हर एक चीज की लोकेशन ढूंढना वाज नॉट डिफिकल्ट एट दैट टाइम, बट प्रॉब्लम ये हुआ कि अमेरिका वाज विद पाकिस्तान। इनफैक्ट ये प्रॉब्लम था कि इन 1971 वॉर अमेरिका सेंट इट्स कैरियर ग्रुप, एयरक्राफ्ट कैरियर का ग्रुप भेजा पाकिस्तान को हेल्प करने के लिए when it was killing a lot of people in Bangladesh. So America was never our friend. In 99 war, they shut down the GPS services and our soldiers were left with nothing. उनको यही नहीं मालूम था कि कहाँ कौन सा दुश्मन जाके बैठा हुआ है। वहां पे जो चरवाहे होते थे वो उनको इंफॉर्मेशन देते एंड दे वुड गो एंड डू देयर वर्क, डू देयर मिशन। So because of that thing, India thought that being dependent on other countries and other people for our own defense is not going to help us। इंडिया के अंदर इतना आतंकवादी आते रहते हैं आए दिन, ये पहले हमको मालूम नहीं पड़ता था, राइट। कहाँ पे आके बॉम्ब धमाके किया हमको नहीं मालूम। बट अभी क्या हो गया है कि जैसे ही नेविक और ये सब लॉन्च हुआ, हमारे आर्म फोर्सेस ने ड्रोन यूज करना चालू किया, तो दे स्टार्टेड हैविंग मोर इंफॉर्मेशन अबाउट व्हाट इज गोइंग ऑन, एंड इसके वजह से हमारे पास अभी डिफेंस के लिए अच्छी खासी अपॉर्चुनिटीज है। बट नाउ कमिंग टू द मेन टॉपिक नाउ, कि हम सैटेलाइट का इतना बात किया कि फार्मिंग, ये तो सिर्फ एक डिफेंस का बात हुआ, स्पेस एक्सप्लोरेशन का बात हुआ, बट सैटेलाइट्स आर आल्सो यूज्ड फॉर फाइंडिंग आउट के कौन सी खेती करना अभी बेटर है। अगर आप गांव के साइड में रहते हो, देन यू माइट हैव सीन के बहुत सारे दूरदर्शन पे प्रोग्राम आते हैं। ओके, सो यस, हाँ, दूरदर्शन पे प्रोग्राम आते हैं, राइट, अबाउट फार्मिंग, जहाँ पे फार्मर्स को बहुत सारी चीजें सिखाई जाती है, लाइक विच फर्टिलाइजर टू यूज, विच क्रॉप टू हार्वेस्ट, विच क्रॉप टू सो राइट नाउ। तो ये सब कैसे पॉसिबल हुआ? एंड अगर कोई प्लांट के अंदर डिजीज होती है तो वो भी उनको बता दिया जाता है। नाउ हाउ इज दिस ऑल पॉसिबल? ये सब पॉसिबल होता है बिकॉज दिस सैटेलाइट्स यूज अ वेरी हाई रिजोल्यूशन कैमरा। ये कैमरा ऐसे होता है कि जो आपको स्पेस में बैठे बैठे आपकी घड़ी में क्या टाइम हो रहा है वो बता देंगे। दे आर सो पावरफुल, राइट। एंड ये सैटेलाइट इतने बड़े बड़े भी नहीं होते, लाइक आपका क्या बोलते हैं, एक कुकर होता है ना, कुकर, इतना ही बड़ा सैटेलाइट भी होता है जो ये सब काम कर सकता है. सो दैट इज द ब्यूटी ऑफ स्पेस टेक्नोलॉजी. अभी ये सब सैटेलाइट का बात किया, बट सैटेलाइट को भेजना हमको स्पेस में है, तो हाउ आर वी गोइंग टू डू इट? आपको क्या लगता है, प्लेन स्पेस में काम करेगा?
यहाँ पे इंटरनेट पकड़ सकता है, यूट्यूब पे पूरा क्लियर.
स्पेस में आपका प्लेन काम करेगा? एनीवन? हेलो हेलो.
यस सर.
हाँ, तो स्पेस में प्लेन काम करेगा कि नहीं करेगा? क्यों?
नो सर. नो
भाई
सर.
नहीं करे.
बट वाई?
वैक्यूम होता है.
ओके, वैक्यूम पर प्लेन में ऐसा क्या है कि वो वैक्यूम में काम नहीं करेगा?
सर वो
प्लेन के
इतना
फ्यूल को बर्न करने के लिए एयर की जरूरत है.
सर
राइट,
उतना
एग्जैक्टली दैट्स द पॉइंट. इसके लिए एंड दूसरा चीज ये है कि सैटेलाइट्स कैन बी रियली स्मॉल एंड दे नीड टू बी लॉन्च्ड इन अ पर्टिकुलर ऑर्बिट. एक पर्टिकुलर ऑर्बिट में उनको लॉन्च करना होता है एंड यू नीड टू हैव सर्टेन स्पीड. जैसे कि अभी 500 किलोमीटर की ऑर्बिट में अगर मुझे कोई सैटेलाइट भेजना है, तो इट विल नीड एटलीस्ट 28,000 किलोमीटर पर आवर स्पीड. राइट, इतना वेलोसिटी उसको चाहिए, तब जाके वो ऑर्बिट करेगा. एंड दैट इज समथिंग दैट अ प्लेन कैन नॉट डू. बिकॉज अगर प्लेन इतनी स्पीड पे जाएगा, अगर आपने SR-71 प्लेन का नाम सुना हो, उसका निकनेम है ब्लैक बर्ड, अगर ये नाम सुना हो तो आपको पता होगा कि वो लाइक कुछ ही 1,000 किलोमीटर पर आवर में जाता था. बट द सरफेस टेम्परेचर ऑफ दैट प्लेन गॉट सो हॉट कि अगर वो लैंड होता था ना, तो लैंड करने के बाद भी आधा पौना घंटा पायलट को अंदर बैठा रहना पड़ता था. ही कैन नॉट गेट आउट, बिकॉज वो बाहर निकलेगा, जैसे ही पैर उसका प्लेन पे पड़ेगा तो उसका सरफेस इतना हॉट होगा कि वो पैर जला देगा, खुद का जूता जला देगा. सो दैट वाज द प्रॉब्लम एंड प्लेन इसके लिए यूज नहीं किया जाता. सो टू टैकल दैट प्रॉब्लम हम नाजी जर्मनी को इतना कोसते हैं, बट द बिगेस्ट कंट्रीब्यूशन टू स्पेस technology nowadays was because of those Germans. No doubt, a lot of countries had developed their rocket engines before that, and in fact, Tipu Sultan used to have a army where they used arrow tied with rocket motors to shoot at the enemy. But if we want to look at a real rocket, then it was Nazi German who built the V2 rocket. It was a missile, right? But after the World War II ended, Americans kidnapped the main scientist, Van Braun, and took him to America. And Russia kidnapped a few scientists and took the technology with them to build the rest of the rocket themselves. तो इसके वजह से रॉकेट बहुत इंपॉर्टेंट होते हैं ये चीज को करने के लिए, टू गेट इनटू स्पेस. एंड जब रॉकेट की बात करते हैं तो वी ऑफन हियर वर्ड रॉकेट साइंस फ्रॉम पीपल. अभी रॉकेट साइंस होता क्या है? रॉकेट साइंस क्या होता है?
The science which is related to launch a rocket or build a rocket.
ओके, ये एक आंसर हुआ. अनदर आंसर?
It is science related to develop and build the rocket.
So rocket science is all about using rocket propulsions to move anything from a firework to
Okay.
manage.
अभी now the thing is,
we can define rocket science like the science of designing or building rockets also, and something that's very difficult to learn or understand the job which is challenging, but it's not exactly rockets. It's about encouraging the science and knowing to how to learn about
Now this is something that I was looking for. Actually, rocket science हम सब बोलते तो है. There is no science called rocket science. Rocket science ऐसा कुछ है ही
Yes,
नहीं.
sir.
The thing is कि rocket science is a field that is merged with a lot of fields. बहुत सारी field का एक combination है. And it is a term used by a lot of people like common people जो field को belong नहीं करते. So for them, a lot of things like a rocket engine or a surface of a rocket is basically just a rocket. But for people who are in this field, there are electronic system. Then you have design engineering, mechanical engineering, aerospace engineering, propulsion system engineers. फिर बहुत सारी and actually the rocket science which we are thinking of is basically what we are referring to is aerospace engineering. जो हम बात कर रहे हैं कि रॉकेट बनाने का जो साइंस है इट इज कॉल्ड एक्चुअली एरोस्पेस इंजीनियरिंग जो लाइक इट इज वेरी इंटरेस्टिंग सब्जेक्ट टू स्टडी इन इंडिया खास करके इंडिया में बिकॉज इन एंटायर वर्ल्ड वी आर द पीपल विथ चीपेस्ट स्पेस रॉकेट्स सब सारी कंट्री से सस्ते में हम मिशन करते हैं so learning that from the scientists who have worked on this rocket it is a unique experience right so हम जब बात कर रहे हैं अभी एरोस्पेस इंजीनियरिंग की मैकेनिकल इंजीनियरिंग की इलेक्ट्रॉनिक्स है फिर इलेक्ट्रिकल है सॉफ्टवेयर सिस्टम्स आ जाता है फिजिक्स केमिस्ट्री मैथ बायोलॉजी स्टैटिस्टिक हर एक फील्ड आ जाती है व्हेन वी आर बिल्डिंग अ रॉकेट जैसे कि अभी जो मार्स पे रोवर भेजा था अमेरिका ने तो दे ऑल्सो नीडेड पीपल फ्रॉम बायोलॉजी टू वर्क ऑन दैट रोवर अभी आप बोलोगे यार विशाल यू हैव गॉन मैड where why would biology people be working on those things अभी चीज ये है कि when you are launching a interplanetary mission you are launching something on the surface of the planet then you have to make sure that you do not send any bacteria or viruses from earth to there right you do not want to send anything that will contaminate that planet so the biology people had to work on each of that sample tube जितने भी वो सॉइल के सैंपल कलेक्ट करने के लिए बॉटल्स भेजी गई थी रोवर के साथ all of those bottles were sterilized they were inspected they were made with the help of biologists right so इसके लिए इतना इम्पोर्टेंट होता है अनदर थिंग कि इंडिया के एक कॉलेज है TIFR टाटा इंस्टीट्यूट ऑफ फंडामेंटल रिसर्च जो डॉक्टर होमी जे बाबा ने बनाया था now the institute had a scientist who discovered that there were three bacteria in stratosphere like almost near to space so बोल सकते हैं कि like almost space condition में भी bacteria ढूंढे Indian scientist ने and out of that one two bacteria were anaerobic जिनको ऑक्सीजन के बगैर वो सरवाइव कर सकते हैं एंड वन वाज एरोबिक सो ये हमारा डिस्कवरी था ठीक सी एंड दिस इज व्हाई बायोलॉजी इज important in this field as well but as of now today my expertise is basically in propulsion system तो हम propulsion की बात करेंगे रॉकेट इंजन की बात करेंगे एंड इट इज वेरी मच इंटरेस्टिंग अगर आप इंटरेक्टिव रहोगे ना इफ यू आर क्विक टू आंसर आई एम assuring you hey you will learn something new from this रॉकेट इंजन के अंदर कुछ ना कुछ आपको नया सीखने को मिलेगा एंड इवन आफ्टर वर्किंग ऑन फॉर 6 years इन दिस थिंग माई सेल्फ आई फाइंड समथिंग टू लर्न एवरी डे इसके लिए मैं कभी बोलता ही नहीं हूँ कि आई एम स्पेशलिस्ट और आई एम दिस और दैट बन ही नहीं सकता Start sharing again. Okay. Rocket. Am I audible?
Yes, sir.
Yes, sir.
Okay, great. So see, just
चाय बल कितना नाम से लेते थे जय जय से
just be quick with answering the questions. गलत होगा तो कोई दिक्कत नहीं. You are still in the school and you have plenty of opportunities to learn. So even if you are wrong, don't be afraid of answering the questions. Okay. यहाँ पे सीखने के लिए आए हैं ना. ज्यादा से ज्यादा क्या होगा कि एक आध आंसर गलत हो जाएगा. नो प्रॉब्लम. कुछ नहीं सीख लोगे. हेलो.
अरे जेल वाला अपन पहले कई 5 दिन उसकी डॉक्यूमेंट सब बने थे.
So okay, I was saying कि मेरा वर्क एक्सपीरियंस बेसिकली रॉकेट इंजन के ऊपर काम करने का, राइट. So we are going to talk about that. So when we talk about engines, as you all said कि प्लेन को चलने के लिए ऑक्सीजन की जरूरत पड़ती है, राइट. And that is why they cannot work in the space. But there are several planes, for example MiG-29 रशिया का प्लेन है. देन SR-71 जो यूएसए का प्लेन है. These plane have the capacity of working in almost space condition. Like अपना ऑक्सीजन जो है it is still available at very high altitude. But वहाँ पे this plane have to work at a lot way high speed. They work at 4 or 5 times the speed of sound. MiG-29 है वो थोड़ा लाइक कम पे चलता है. बट जो SR-71 ब्लैकबर्ड है इट गोज अप टू 3.33 मैक. मतलब 3.33 times the sound of speed of sound. So that is the problem. But the engines that are used in rockets, they basically work on the third uh, principle of Newton's law of motion, which is that momentum. Momentum is maintained in the entire system. तो लाइक होता क्या है कि व्हेन यू स्टार्ट रॉकेट इंजन तो होगा क्या कि प्रोपेलेंट आपका जलेगा एंड द प्रोपेलेंट हैव अ मिक्सचर ऑफ ऑक्सीजन इन एंड फ्यूल. So what happens is कि ये जो gases निकलते हैं now these gases are not just flame or something, but these are very highly excited molecules. अभी आपको जैसे कि समझ लो कि बिगर काम की मैंने अगर पिज्जा पार्टी दे दी तो आप तो खुश हो जाओगे. यू विल गेट एक्साइटेड, यू विल स्टार्ट रशिंग हियर एंड देयर. आप घर पे जाके भी इधर उधर भागा दौड़ी करोगे, राइट. Why? Because I have given you energy. I have given you some energy in the form that I am giving you a party in evening. So you will remain excited and you will rush here and there. And now compared this to being in a mathematics class. I was never interested in mathematics class, but I learned it my way. So what happened was, even though I was excited and I got into mathematics class, and when they started talking about second order differentiation, integrals, this and that, I got bored and I lost my energy there. So this is something that also happens in a rocket engine. So when the propellant starts burning, these all propellants are very highly energetic compound, right? अभी हाईली एनर्जेटिक कंपाउंड को अगर लोकल लैंग्वेज में मैं बोलने जाऊं तो एक्सप्लोसिव्स. प्रोपेलेंट्स आर नथिंग बट कंट्रोल्ड एक्सप्लोसिव्स, राइट. इनफैक्ट मिसाइल जो होती है सरफेस टू सरफेस, सरफेस टू एयर, एयर टू सरफेस, तो ये सारे के अंदर लिटरली RDX, TMT, HMX, ये सारे के कॉम्बिनेशन यूज होते हैं, राइट. यू माइट से कि TNT RDX यूज होता है तो फट नहीं जाता. नाउ दैट इज द थिंग. Rockets are nothing but a vehicle that moves with the energy of controlled explosion, right. अभी रॉकेट इंजन के अंदर आप थोड़ा ज्यादा फ्यूल डाल दोगे इट विल एक्सप्लोड. इट इज वेरी थिन लाइन बिटवीन एक्सप्लोजन एंड combustion. So this happens, and when the combustion is taking place, तो समझ लो कि अभी केरोसिन और ऑक्सीजन वाला
Vishal Kahar ji, Mr. Vishal Kahar ji,
यस
this is Dr. Mani Mishra. Sir, here I would
यस
like to ask one question.
श्योर 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 यस सर यू कैन आस्क योर क्वेश्चन
Sir, what is the difference explosive and controlled explosive?
okay so see if I take a grenade and take the pin out and throw it, what happens is uncontrolled explosion, like right, but not exactly uncontrolled because you are calculating how much range of explosion do you need, how much explosive you have to fill in the grenade, or how much you have to do. It is very calculated thing, and that is why it is called controlled, because you can control the parameters. Because for example, just imagine that you have a rocket engine with 8 kg of propellant, right? It is similar to having a 8 kg bomb near you. And if you have not calculated it properly, what happens is when the propellant starts burning, it also creates pressure. All of the rocket engines have to work at a particular combustion pressure in the combustion chamber, because if that doesn't happen, the rocket won't even lift off from the ground. So that is very calculated. For example, if now I am developing an engine, right now I am developing an engine, and I need it for this prototyping purpose. So the combustion chamber pressure is kept just to 50 bar, like 50 times higher than the atmospheric pressure. Okay, but 500 times the atmospheric pressure. But if I have to make a missile, I will have to do a more pressure there. But just imagine if the calculation is not proper, and if I make the nozzle smaller than it has to be, what will happen is it will create more pressure in the chamber. And if the material is very calculated, what will happen is the missile will explode, because we made the material weaker than it was supposed to be, right? So that is the difference between a controlled explosion and a normal explosion. Like if you have seen the video from Beirut, Yemen, a few years ago, there was ammonium nitrate stored there, and they were unaware of it, and it suddenly exploded. So it what it did was it grounded entire city. It literally destroyed buildings near it, windows, buildings, lives, everything. It was destroyed. That was uncontrolled explosion. Now, when we are talking about control, what happens is when we are talking about Apollo 11, we are talking about Gaganyaan, we are talking about space shuttle, we are talking about Soyuz. Now we see these all astronauts are sitting on top of millions of liter of propellant below them. If the rocket explodes, they are going to be killed in no time. And it actually happened with Kalpana Chawla. So जब they all were launched, the rocket had some combustion instability जब होता है तो वो explosion हो जाता है वहां पे, and because of that entire space shuttle was destroyed. So this happens, and that is why the guy who told कि rocket science इतना easy लगता है, इतना है नहीं. A lot of space educators in India nowadays say that rocket science is not rocket science anymore. It is wrong, because when you are talking about actual rocket, it is very complicated, but not impossible, of course. So I hope I have answered your question. Okay, so going
Yes, sir.
ahead,
Thank you.
you're welcome, sir.
Thank you, Vishal
So
ji.
going, yes, sir. So going ahead, rocket engines की जब बात करते हैं, तो now we are also going to talk a little bit about normal vehicles like car, bike, ये सब की. So now I know that boys are very much interested into cars, and especially sports car. So if you have heard about Ferrari, or if you have heard about Lamborghini or other cars, You might have heard that this car is capable of going from 0 to 100 in 6 seconds or something like that. You might also have heard that this car has 70 horsepower of energy or something like that, or this car has 60. This car has a V8 engine with 8 piston or something like that, right? Or this engine is turbocharged. Now these are all things which we use to describe the engine of a car. We have to talk about bike, we talk about internal combustion engine, we talk about 125 cc engine. If we are going on scooty, we'll say okay, my scooty is 70 cc. If I'm going on exercise, we'll say I am going on 125 cc. तो ये होता क्या है कि 125 70 cc क्या है? तो 70 सीसी जो है वो जो अंदर पिस्टन होता है, पिस्टन और जो चेंबर होता है उसका कंबशन चेंबर, उसके बीच का जो वॉल्यूम होता है ना, उसको बोला जाता है. सो 125 सीसी मीन्स कि 125 ml का वॉल्यूम है अंदर, राइट? सो दिस आर chemical, nuclear, electrical, photon, solid and solar cell. पर जो मेन हम बात करेंगे will be chemical propulsion, electrical propulsion and solar cell, because these are the most used solar system, this propulsion system now, right? And जो भी रिसर्च किया जा रहा है ना अभी, वो भी ये सारी फील्ड के अंदर किया जा रहा है. सो गोइंग अहेड विद दिस, केमिकल propulsion नाम से पता चल जाता है कि केमिकल्स होंगे इसमें. सो मेरे को स्टेट्स ऑफ मैटर कितने हैं वो कौन बताएगा? हाउ मेनी स्टेट्स ऑफ मैटर आर देयर?
5 states of matter.
Five. There are
कौन से
five states of matter.
फाइव? एक्चुअली सिक्स है, सिक्स है, बट फाइव कौन से है?
Solid, liquid, gas, plasma,
लिक्विड गैस,
boss, and
प्लाज्मा,
condensate.
Solid, liquid, gas, plasma, Boss incident.
ओके सॉलिड गैस.
There are 7 types of matter. It contains solid, liquid gases, ionized plasma, quark, glucose plasma, Einstein condensate, and fermionic condensate.
By but yes, there are five top.
Seven stages of matters are there. Yes, sir.
Okay, so five states of my presentation stopped. Hold on. Okay, so the five states of matter that are solid, liquid, gas, plasma, Bose-Einstein condensate, and antimatter. Six, right? So now basically for propulsion system purpose, we use solid, liquid, gas, and plasma, right? Bose-Einstein condensate is just for theoretical physics and all those purpose, not for propulsion, because it takes energy, it doesn't give energy, right? Yes. So we start with the first state of matter, which is solid, and as the name says, it is about solid propellant, right? See, the rocket, we scientists or the scientists have very basic knowledge of naming things. We don't name things a lot complicated. We need it easy. So solid propellant use कर रहा है, solid propellant है, solid propulsion नाम डाल दिया, solid rocket डाल दिया. And why do we call it motor? Because it looks cylinder to us. इसके लिए उसको solid rocket motor बोलते हैं. And if you are talking about the boosters that are tied around PSLV. We call it strap-on booster. Why? Because उसको बस हमने strap कर दिया उसके ऊपर. We have not fixed it. वो just ऐसे बांधा हुआ होता है ना. So it is strapped like that. It is actually hold on by two explosive on the PSLV or the rocket that uses the boosters. So what is special about these boosters? इसके अंदर solid use होता है, right? और the thing is that solid booster होता है. They have to be filled a lot time earlier. वो बहुत टाइम पहले ही उसको फुल फिल करके रख दिया जाता है. It is stored, can be stored, and this is the reason why it is used a lot in missile application. And especially when we are talking about intercontinental ballistic missiles, or for example, Agni 5, Agni 1, 2, 3, 4, 5, then Prithvi, Nag. So all of these uses solid propulsion because they are reliable. वैसा सबसे भरोसेमंद बंदा होता है, right, of the class, like the first bencher. If you tell it to go and get something done, it will get it done. खड़ा होकर निकल लेगा, it will get the things done. प्रॉब्लम ये है कि एक क्लास का वो मोटा बच्चा है जो भागेगा, तो अगर रुकना होगा तो रुक नहीं पाएगा, राइट. तो द थिंग इज, सिंस द प्रोपेलेंट्स आर ऑल मिक्स्ड अप वे बिफोर, इट कैन नॉट बी कंट्रोल्ड, राइट. अभी अलग है, अभी ऐसे सिस्टम बन रहा है कि जो कंट्रोल किया जा सकता है सॉलिड प्रोपल्शन, बट इट इज नॉट एग्जैक्टली सॉलिड. इट इज कॉल्ड ऑटो फेज रॉकेट इंजन. इफ यू वांट टू सर्च इट, वो उसमें they vaporize this solid propellant and then combust it in the chamber. So it is not exactly solid propulsion, but yes, you get the idea. It is controlled thing. So this thing are very bulky, right? They weigh a lot of tons. Why? Because they are less efficient. एक फैक्टर होता है, जैसे कि हम गाड़ियों की बात करते हैं ना, when we are talking about cars, we talk about HP, right? Horsepower of the car. We talk about the engine, the power the car gives. So when we are talking about rockets, we talk about IST, which is specific impulse. Now this factor is to give us the performance factor that how much thrust can we get from 1 kg of propellant, right? So now these propellants are among the least, energetic propulsion system, because the engine can go maximum up to, like the civilian one, they can go maximum up to 160, 170, right? So it is not a big that factor. So because of those two problems, we came to another problem. Like, okay, we cannot control the combustion. So how do we do that, and how do we improve the efficiency? So what the scientists did was converted one factor of the solid propellant into gaseous or a liquid stage. So what they did was they made solid propellant grain from wax or from plastic or from rubber, and they chose an oxidizer which is liquid oxygen or nitric acid or nitrous oxide, liquidated, or hydrogen peroxide. So all of these are used for oxidizer purpose in hybrid engine. So now what happened is that the system became more efficient, क्योंकि अभी combustion ज़्यादा properly हो रहा है, it is mixing properly. But now bigger problem arise कि हमको pressurized oxidizer store करना है, then it will need a heavier propellant tank, and rocket जितने lightweight होता है इतना better है, because see, there is another factor when you start building the rocket, which is called PMF, propellant mass factor, right? And then you have WTF, weight to thrust ratio, thrust to weight ratio, TWR, thrust to weight ratio. So what happens is we have to see that we are creating thrust and we have weight of the rocket. So we have to balance it out such that it goes at a particular speed and at a particular altitude to launch the satellite. So अभी जब मेरा rocket heavy होने लगेगा ना, तो I would not be able to carry a bigger satellite with me. And because of that, मेरा पूरा space mission का cost बढ़ जाएगा, right? अभी जैसे कि मेरा एक hybrid engine वाला rocket होगा, and if it's taking me around 10 lakhs to make it, but I can just launch 1 kg from it. तो कोई launch ही नहीं करेगा. Why will someone pay me 1 lakh, 10 lakh to launch a rocket, satellite? जो वो लोग 1 लाख में कर सकते हैं, they won't do it. So इसकी वजह से this kind of boosters are used basically in fantasy projects. अभी जैसे कि अगर if you have heard about a car that Americans are building which uses solid this hybrid engine. तो वो क्या करते हैं कि डेजर्ट में जाते हैं हाइब्रिड इंजन को यूज करके दे एंड दिस आर आल्सो यूज्ड इन मिसाइल पर्पस. अभी मिसाइल पर्पस के अंदर ये ऑक्सीडाइजर को स्टोर नहीं किया जाता बिकॉज इट इज गोइंग टू वर्क इन द एटमॉस्फेयर. तो होता क्या है कि एक सॉलिड प्रोपेलेंट का ग्रेन होगा आपका stored in your propulsion chamber and you will have heating coil near it जो आपके प्रोपेलेंट को वेपराइज करेगा अंदर. एंड व्हेन द मिसाइल स्टार्ट्स गोइंग अलोंग विथ पहले तो उसको बूस्टर से लॉन्च किया जाता है एंड व्हेन द एयर स्टार्ट्स कमिंग इन द एयर इनटेक then the fuel mixes with the air and then the combustion starts taking place. So this makes the entire missile very compact. तो वहाँ पे एक एप्लीकेशन है बट फॉर लॉन्चिंग सैटेलाइट्स इट इज नॉट यूज्ड. So to come across to solve this problem, scientists converted another vector into liquid, and that is how we get the backbenchers of solid propulsion, not solid, but the chemical propulsion system. And this is the godfather of all space missions, liquid rocket engine. Whether it is Chandrayaan 1, Chandrayaan 2, Mangalyaan, James Webb Telescope, or RISAT or GSAT, name satellites, there will be a liquid rocket engine on that particular payload, right? And why is it used? Because this gives the highest IST of all chemical propulsion systems. Liquid hydrogen, liquid oxygen engine that were used on space shuttle mission. They had ISP of 340 Newton second. Now just imagine, you are getting 340 Newton of force from each kg of propellant, and the temperature of that engine inside was around 3400 degrees Celsius, and बाहर के surface पे बर्फ जमता है. So just imagine how complicated and calculated those engines are. That अंदर के side पे almost sun का temperature and बाहर बर्फ जम हुआ because it uses liquid hydrogen to cool the engine. And this engine is my favorite. So talking about this, इसमें दोनों side liquid use होता है. तो now give me one example of liquid fuel and liquid oxidizer. Give me an example. Anyone? Yeah, no one.
So what the question?
आवाज आ रहा है मेरा?
No, sir.
अभी अभी आ रहा है?
Yes, sir.
तो मतलब अभी तक नहीं आ रहा था मेरा आवाज?
Sir, your voice was coming, but we are unavailable to hear what's the question.
Okay, so my question is, give me an example of liquid fuel and liquid oxidizer.
One example of liquid fuel. Sir, one example of liquid
Kerosene.
fuel.
Yes, kerosene.
Sir, kerosene
And
fuel, petrol.
Petroleum.
Yes,
And
and oxidizer.
Natural gas.
Yes, Yes, but now give me an example of oxidizer. I know one thing कि एक बंदा अगर जवाब देगा then everyone starts answering about it. But now give me an example of liquid oxidizer.
Liquid oxidizer.
Liquid oxygen.
Yes, yes, that's the answer. Like you see,
Sir, nitric
this
acid.
is yes nitric acid, but you know the nitric acid that is used
Nitrogen
for
Ammonium nitrate.
nitrogen
yes,
tetroxide.
yes, but now see, the thing is the beautiful thing about oxidizers is that when someone asks you what is a liquid oxidizer, so oxygen and oxidizer have very similarity because it literally is the definition. Like addition of oxygen is called oxidation, and that is why oxidizer is the best form of oxidizer is liquid oxygen. Nothing better than that. So yes, so in liquid engine, you have a lot of combinations of this kind of propellants. For example, someone said natural gas. So it's not, exactly natural gas that is being used. It is basically methane, somewhat similar to biogas, right? CH4. So liquefied CH4 is used by Raptor engine that is being made by SpaceX. So other than that, uh, kerosene oxygen is used, right? Then we have ethanol oxygen, we have
Al-
ethanol nitric acid, then we have
alcohol.
UDMH, yes, alcohol, then we have UDMH hydrogen, then UDMH nitrous oxide, tetroxides. So yes, those are a lot. There are a lot of combinations of these propellants. So what happens is, all of these components are very energetic. So in combustion chamber, what we are doing is we are making ganne ka juice out of this propellant. What we do in ganne ka juice, we put the sugar cane in that machine. उसको हम तब तक पास करते रहेंगे जब उसमें सारा रस निकल चुका हो. We'll try to get everything out of it, right? So similarly, engine के अंदर क्या होता है कि all of the compound that we have on our planet, they all have energy in them. Atoms जो होते हैं ना उनका खुद का energy होता ही है. It is called free energy or enthalpy, free enthalpy. So when we are talking about engine, we are talking about high pressure and temperature. Like literally, the SpaceX is going to 330 bar pressure, 33 megapascal. Okay, 33 मेगापास्कल के प्रेशर पे जब प्रोपेलेंट्स को कंबशन किया जाता है, they are trying to get that every single percent out of that uh, atom's energy to use for propulsion. होगा क्या कि उसमें से एनर्जी निकलेगा ना, that particle will be accelerating so fast out of the nozzle that it will be exerting similar force on the engine. एंड इसका पर्पस ये है कि स्टारशिप is to be reused and used again and again, right? To send humans from Mars to Earth to Mars and Mars to Earth again. And surface, the atmosphere on Mars is very thin. तो वहाँ पे पैराशूट बहुत बड़े बड़े चाहिए. तो इंस्टेड ऑफ दैट व्हाट वी आर डूइंग इज वी आर यूजिंग propulsion टू डीएक्सेलरेट आवर रॉकेट. होगा क्या कि वहां पे लैंडिंग के टाइम पे वो रॉकेट इंजन फायर करेगा. इतना ज्यादा प्रेशर आ रहा है वहां पे नीचे है कि 3 इंजन से ही वो स्लो डाउन करके लैंड करेगा इतने हैवी रॉकेट को. सो दैट इज द पर्पस व्हाई वी यूज सच हाई प्रेशर एंड टेम्परेचर इन रॉकेट इंजन. हमको एक एक परसेंट एनर्जी निकालना है वो चीज का. So now when we are using such a high temperature and pressure, every metal, literally every metal that you point will melt at that temperature. 3400 डिग्री सेल्सियस पे कोई मेटल नहीं है, टाइटेनियम कार्बाइड कुछ भी बोल लो, कुछ नहीं टिकेगा इतने टेम्परेचर पे. इनफैक्ट इवन यू टॉक अबाउट स्टील, स्टील होगा ना वो मक्खन के जैसे आपका पिघलेगा लिटरली. इफ यू हैव अ कैटास्ट्रॉफी और problem with rocket engine and it starts melting inside, तो इंजन आप शट डाउन करोगे ना, तो वहां पे पूरे का पूरा आपको ऐसे बॉल मिलेगा मोल्टन मेटल का, बटर बन जाता है उसका। सो टू प्रिवेंट दैट वी यूज समथिंग सिमिलर टू पर्सपिरेशन। हमको जो पसीना आता है ना, वी यूज समथिंग सिमिलर टू दैट, एंड इसको बोला जाता है रिजेनरेटिव कूलिंग। सो यहाँ पे आपको इतने सारे पाइप्स दिख रहे होंगे यहाँ पे बाहर, राइट, विजिबल। आई विल एनसर्कल इट, सी, एक पाइप हो गया, ये नीचे पाइप हो गया, then we have this cooling manifold here, then we have here. So this this is all visible, right? It, I messed up. Okay. Okay, so wait a minute. Okay, um, okay, so here's the spotlight. So you can see here, right? Is it visible? The, like, here is one manifold, then here is one manifold, then here it is here. So these all are used for pumping fuel in the wall here. See, I will, highlight the wall. If you see, this entire engine is not made in. Okay. So this entire engine is not made with one particular point, right? If you zoom in, then you will see that there are holes in that wall. So it is called a cooling jacket, right? So हमको पसीना आता है तो हमारा बॉडी कैसे ठंडा होता है? हाउ डज इट वर्क? आंसर इट।
Cooling effect of evaporation.
क्या?
Cooling effect of evaporation. When something
कूलिंग इफेक्ट होता है, बट हाउ?
when something in the surface is trying to convert its state into a liquid to a gas, it's absorbs
Yes,
some energy from
yes.
the
See,
backward substance. That is cools
now
them. That's
everything has tendency of two things. Either it will give energy or it will absorb energy. Water has high latent heat. Like it takes a lot of energy to increase the temperature by 1 degree Celsius. So what happens is when we start sweating and the sweat gets on our head, it will take heat from our skin and it will convert into water vapor. That is its tendency, and that is how it takes the energy from our skin. It is not taking away the temperature, but it is taking away the heat. Okay, heat and temperature are two different things. Temperature is the total amount of heat that is given to a particular matter, and the rise in its a physical parameter, right? Heat is not a physical parameter, it is a form of energy. So when we are talking about rocket engines, the metal gets heated at thousands of degree temperature. And here, when we talk about cooling effect, the cooling is still the cool side is still 600, 700 degrees Celsius hot, right? That is cool for us. So why do we need to bring it down to 300, 400? Because the metal can handle that temperature, but it cannot handle those thousands of degree temperature. So when we start pumping this propellant in these walls, you know there is this particular thin wall cooling jacket, so it will start taking the heat from the combustion chamber, and because it is already heated at that high temperature, what will happen is that heat transfer is fast. By the uh, when the propellant is pumped into the engine, it is entered at around temperature of 30-40 degrees Celsius. But by the time it is reaching the top side of the engine, it is already heated around 100 degrees Celsius. So that high energy absorption is there. So that is how it maintains that structure. And after this, talking about these things, we go with the most favorite engine I have. And why is this particular engine so important for us to discuss? Because it is literally used in every space missions, deep space missions. Like you name a deep space mission, this will be there. Why? Because ISP, okay, so ISP of liquid engine was around 340 maximum. Now ISP for iron thruster is 1500 second. 1 kg of propellant will give you 1500 Newton of thrust. And how does it do that? So, since now all of you are talking much about science, so I think I can go a little bit into scientific terminology. So, see, ये इंजन के अंदर क्या होता है कि क्रिप्टॉन गैस एक अपना इनर्ट गैस है, राइट? हीलियम, नियॉन, आर्गन, रेडॉन, क्रिप्टॉन। तो उसमें क्रिप्टॉन है एकदम डाउन बिफोर रेडॉन। तो वो सबसे हैवी है, हैवीएस्ट ऑफ ऑल गैसेस। तो इसको स्टोर किया जाता है एक चेम्बर में, टैंक में। एंड द चेम्बर जो होता है इसमें हॉल इफेक्ट यूज किया जाता है। हॉल इफेक्ट क्या होता है वो भी बताता हूँ। एक बहुत हाई करंट का एक कॉइल होता है, राइट? बहुत हाई करंट पास किया जा रहा है एंड देन यू पंप अ लिटिल बिट ऑफ क्रिप्टॉन गैस ऑन इट। तो क्रिप्टॉन जैसे ही ये हाई करंट के कांटेक्ट में आता है तो इट गेट्स पॉजिटिवली चार्ज। एक इलेक्ट्रॉन उसमें से निकल जाता है, इट गेट्स आयनाइज, और एक पॉजिटिव चार्ज आ जाता है उसमें। एंड व्हेन इट गेट्स पॉजिटिवली चार्ज वो क्या करेगा कि बाहर मैग्नेट होता है। सो इट इज नाउ टेंडेंसी दैट एवरी आयनाइज्ड पार्टिकल हैव समवॉट ऑफ अ मैग्नेटिक इफेक्ट। तो मैग्नेट के तरफ तरफ ये भागेंगे। एंड द क्रिप्टॉन गैस इज सो हैवी कि भागते भागते इतनी वेलोसिटी गेन कर लेते हैं कि इट विल जस्ट एग्जिट द इंजन, इट विल एंटर इनटू स्पेस। सो ये चीज से हॉल इफेक्ट थ्रस्टर, आयन थ्रस्टर भी बोलते हैं इसको। सो इट गेट्स एनर्जी फ्रॉम दैट। एंड जो ये ऊपर ब्लू हमको लाइट दिख रहा है ना, इट इज नथिंग बट इलेक्ट्रॉन्स दैट आर बीइंग लॉन्च्ड बैक इनटू द स्ट्रीम। तो इस स्पेस के अंदर हमको कुछ भी आयन चीज भेजेंगे तो इट विल कम बैक टू द स्पेसक्राफ्ट, राइट? सो यू हैव टू न्यूट्रलाइज देम। सो एक बार ये पॉजिटिव आयन निकल जाता है देन यू आल्सो लॉन्च द इलेक्ट्रॉन्स बैक आउट देयर। सो यस, दिस इज हाउ द इंजन वर्क्स। एप्लीकेशन कहाँ पे वो भी समझाता हूँ। अभी ये जो सारे इंजन हमने पहले देखे, केमिकल प्रपोजन, वो मिलियंस ऑफ केजी फोर्स हमको प्रोवाइड कर सकते हैं। This engine can give us the maximum thrust of around 5-10 Newton thrust. Okay, so that is why it is used in deep space missions where uh, there is no environment. Okay, there is no atmosphere. Like there is, but it is not significant. So the spacecraft can travel without any problem. So 5 न्यूटन का थ्रस्ट प्रोवाइड करते जाएंगे धीमे 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 धीमे। सो दिस इंजन कैन वर्क फॉर मंथ्स एंड years। सो मंथ्स कॉन्स्टेंटली आप एक हफ्ता तक उसको 5 न्यूटन का थ्रस्ट दे रहे हो, so it will have gained a lot of energy by the time you turn off the engine। so इसके लिए यूज किया जाता है वहाँ पे। after that we are skipping some and we are getting onto solar sail। तो सोलर सेल का क्या काम है? अभी मंगलयान जो है ना, if we didn't have this kind of mindset of using everything possible out there, we wouldn't have been able to achieve the success on the first trial for Mangalyaan mission। So the entire Mangalyaan, if you see on the 500 कौन सा नोट है वो भूल गया, most probably 2000 का नोट है, तो उसके ऊपर अपना मंगलयान का फोटो है, राइट? So if you see it properly, the design is such that when it got into space, it took the energy from radiation। Solar storm भी जो हुआ था ना, it didn't launch a lot of asteroid or something like that। It launched ionized plasma onto it, and the ionized plasma होता है तो इसका भी weight होता है। And this big sail works more like the sail we have here on the earth। सेल बोट होता है तो ये क्या करता है कि विंड मूव करती है, राइट? नाउ द विंड इज नथिंग बट द motion of the sail. Hello. This is going to be the last. Okay. Almost खत्म हो ही गया है. Hello, everyone back.
हाँ विशाल जी बहुत
Okay, okay, okay. So, starting back, we were talking about this. Wait. We were talking about ion thruster and solar cells. We were talking about solar cells. So I was talking about कि मंगलयान जो हमने किया, it used all this plasma and we are when we are talking about sailboat on Earth. So sailboat क्या होता है कि wind energy use करके travel करता है, but when we are talking about wind, normal people see it just as air. But when you are from scientific community, you see it as a particle of atoms of nitrogen, oxygen, krypton, argon, every other gases, and those are all moving and falling onto your sail and giving it the energy. Okay, so अभी होता क्या है कि when this energy is transferred to you, you start gaining speed, you start gaining energy. Okay, so this is the same concept that we use for solar sail. But apart from this, the most interesting thing about this particular type of system is that कि एक तो पहली चीज के स्टोरेबल होता है, लाइक यू डोंट नीड any kind of propellant on board. You can travel just with the help of radiation. And पूरे सिस्टम के अंदर इतने सारे स्टार है, you get radiation from everywhere. So that is one thing. But another thing is that the sail can also be used to deorbit the satellite. अभी हमको एक चीज मालूम है कि satellite have been launched in so big number in space that it has become a space debris problem. Like, इतना कचरा हो गया है स्पेस के ऑर्बिट में कि it is destroying satellites. Now it is not a new thing for us to hear that satellite crashed into each other. Now it was a rare thing to happen back 10 20 years ago, but it is now more common, right? And several satellites have to do stunts, they have to maneuver to avoid this kind of space debris. And so this kind of sail drag sail is used at the end of the mission when the satellite is about to die. What happens is they trigger a signal which launches this solar sail. It deploys this solar sail, and then the satellite starts deorbiting. So instead of taking a year or half a year, 1.5 year, now it takes about 3 months to deorbit such CubeSats, and it enters the atmosphere and it ends up burning out. So those are something I was about to talk about. Propulsion system. Now, just a quick, cover of sounding rockets. I skipped this. I skipped two topics. One was aerodynamics and one was avionics. But I will give you some links that you can go to and learn about it. It is not, a lot complicated. And if you want to learn about the basics, but yes, it is a deep field. So sounding rockets are basically like a toy car. If you want to learn about car, if you want to learn a car, if you want to learn about some expensive car like Mercedes or something like that, but if you don't have a budget for that, so what will you do is that you will get Honda or you will get Toyota or some cars like that, right? Which will uh, be more suitable for your need for a cheaper transport vehicle, right? And for a regular purpose. So sounding rockets are basically small rockets with just 50 60 kg payload capacity. So what they do is they assemble this kind of rockets with solid propulsion system and they launch experimental payloads on it. So what happens is when you launch this thing, they go straight up, and they are not used for much used for orbital thing, but used for experiments. Like recently, India tested its scramjet engine on Rohini booster, which was a part of sounding rocket, right? Rohini is Indian sounding rocket. Then you have Black important for us to know about it. कोई नहीं है? Anyone? Okay. So
Sir,
the first
sir,
rocket that
what?
we went to,
Sir, what is the
yeah,
question, sir? सर क्वेश्चन क्या है सर सुनाई नहीं दे
the
रहा है
question is why why is Nike Apache rocket so important for us?
सर वाई
Why is Nike Apache rocket important for us?
लाइट अपाची रॉकेट
Lightning, Nike, Nike, Nike Apache.
लाइट is useful for us. Sir, I
Yes.
think
Why is it not useful, but important for us to learn about it?
sir, I
Nike,
think
Nike Apache.
sir, I think Nike Apache rocket, which is I think also known as Argo B-13, was two-stage sounding rocket, which was launched to develop Aerolab later Atlantic research for use by the United States Air
This is a
Force.
Google answer. I know that. It is a Google answer. So your answer is invalid. It is important for us because it was the rocket that we used for the first time to enter space. When Dr. Kalam and his team went to USA in Maryland, they learned their basics on Nike Apache rocket. So it is not about Google answer about developing something for America. It is something that we use to enter in space race, and that is why it is important for us to learn about it. Yes, it is a two-stage engine, two-stage vehicle, but that was not my question. I was asking why it is important for us to learn about it as Indians, because people, in fact, including Amul, there are a lot of brands, Times of India, Amul. These brands have mocked Indian space organization quite a lot time. When GSLV Mark III flew for the first time, it was called the Fat Boy back then. So when it failed, there were news articles which said uh, Indian Space Research Organization loves space, loves ocean, and that is why GSLV Mark III went into ocean. When missile test once failed, they said the same thing, and that is why when we started working on SLV 3, right, where Dr. Kalam was the chief to design the stage 4 for the engine. They had one problem once, like when there was a UDMH leak, right? The propellant was leaking out of the system, and they had all the alarms going on, and they chose to abort the launch and postpone it. These brands were Amul made a poster with an Indian farmer standing with a buffalo out of a space club where USA and UK were sitting inside. And it was only after launching the Mangalyaan mission when the thing changed. When the GSLV Mark III was launched, the thing changed. And that is when the Indian farmer was sitting in the space club and all others were knocking on the door. So this is why it is not just about giving a space exploration thing, but it is more because being a part of aerospace community of India, it is my role and my responsibility to show you all the history that we have come from being mocked by space organizations that were way ahead of us. When USA went to moon, we didn't even have a rocket, but now we have indigenous manufacturing of our own propellant tanks. We have done Mangal mission, Mars mission in the first time that NASA failed to do. We are planning our own astronauts. We are making our own space shuttles. We are making our own crew capsules. And that is why it is important for us to learn about Nike Apache. Because these astronauts went there. Dr. Kalam went there after he lost his father, after death of Dr. Vikram Sarabhai. It was a crucial time back then. We were almost entering into a war with Pakistan. In 1971, we had a war with Pakistan, right? So that is why it is a lot of importance because see, now India is a company who is carrying Pakistan Space Agency. I read an article few days ago. I mean, let me give you these resources. Take a screenshot, and then I will talk about this thing. So take a quick screenshot and let me know once you are done. Done? Done? Okay. So this is another book. These are another. So you can learn things that I haven't covered in this from these books. So yes, I will stop my presentation now. And yes, so going to Indian space history. See, I don't know if you all have heard about or watched the movie Nambi, Rocketry, the Nambi effect. But let me talk about it. See, Indian space history has been so progressive and so dedicated. We have had scientists who came with nothing, gave their everything for us, right? Dr. Kalam went there after his father's death. His brother-in-law also died during that time. So he went there. He lost a lot of part of his family, but he still chose to go there for us Indians. There, okay. They stayed there for a while. There he saw the first photo that Tipu Sultan was in fact the guy who brought rocketry to India. India was the pioneer of rocket and rocket science. When the British came into India, they took around 700 of these rocket motors back in UK. So if you ever happen to go back to UK's British Museum, you can say it is a chore bazaar, right? Why? Because they have everything stolen from the colonies there, right? From Indian rocket motors to our Kohinoor, whether it's our artifacts, they have all there. Chor bazaar, right? So from there we became a country. Now I was talking about that article that I read. It was, a well-known Indian news agency. So they had said that Pakistani space agency scared of Indian space startups. Why? Because all of these space startups are now guided and mentored by these ISRO scientists who worked in zero resources. Just imagine this: we were planning Mangal mission, and the government wasn't interested in funding it. Our government will easily fund something which is of no worth. Our celebrities and in fact our public is so worthless. To be honest, I might sound rude and I might sound angry, but this is the reality. Our population is worthless, right? Our population are paying money for movie stars. They're spending money in Salman Khan, they're spending money in Akshay Kumar, Ajay Devgan. Now these are the people who are selling Vimal instead of spending money on scientific research. Now the guy Nambi, Dr. Nambi Narayan, is the pioneer of making the Vikas engine, right? Now just see how geopolitical situation was there. India was developing a cryogenic engine along with France and Russia. So if India had got cryogenic engine in 2007, India would already be equal to NASA right now. We would have done Mars mission with accuracy and a much bigger payload. See, India was the first country to find water on moon. That is now being verified by NASA. It is now being verified by them. It was first us, right? We did that. We went to Mars on the first time with light satellite, right? We didn't have much budget because our government was not ready to spend money on space mission. They would rather spend it on political agenda, not on space mission. So they did that, but our scientists somehow managed to do the mission in 400 crore and use some old parts from Chandrayaan 2 that was postponed back then, and that is how we made that happen. So whenever I see youngsters like you all going after Bollywood stars, it gets me angry. It pisses me off
विशाल जी,
because this Nambi guy. Yes,
सॉरी टू इंटरप्ट यू, कितना देर और लगेगा?
10 minutes most, maximum 10 minutes.
ठीक ठीक है।
So see, this Nambi guy, Dr. Nambi Narayan, made a Vikas engine, and he was jailed by Kerala state government. Why? Because he had allegations that he was spy and sent blueprints to Pakistan. Now just imagine if it's a cryogenic engine which works with liquid hydrogen oxygen. If it was so easy to make it from one photo that was already available in news agencies, wouldn't Pakistan already be leading us? They would be, but they are not, because it takes years, literally decades, to develop an engine. And me working myself in this particular field, I spent 6 years in developing a solid rocket engine for my company. Now I am putting all the experience, and he was tortured by FBI. FBI is
Okay. Okay. Yes, Manu Misra ji, please.
Hello, am I audible? Sorry,
Yes, yes.
my network was problem. So yes, the only thing I want to say at the end is go and watch this movie, and instead of getting into anything political in the future, or getting into something that is basically dividing our country, rather focus on developing something for our nation, right? See, Ravi ji has worked in hydroponics and all these things, and at the end now he is using that for development of our country, right? He's developed a network for all these people who are experienced in this field to give you all the knowledge we have acquired with all these years. So instead of going with what government is doing, divide and rule, go with one nation, one mindset, one goal, better future for our country. That should be your target at the end. Your next and you be the next Vikram Sarabhai. Because at the end, when you are going to, go into heaven, you are going to face all of them. There would be Dr. Satish Dhawan, there would be Dr. Kalam, and there would be Vikram Sarabhai, there would be Dr. Omije Baba. You'll have to answer them. What did you do for our nation, right? So work with that mindset. With that, I would like to conclude my presentation.
Thank you, Vishal Kaharji. My dear children, apart from technical glitches, respected Vishal Kaharji, who is highly learned person and scientist of space science, he has given wonderful information of rocket science. Now I would like to request my director, sir, Parveen sir, to say a few words of blessing on this program. मैं हमारे डायरेक्टर सर सुन रहे हैं, परवीन सर, मैं चाहूंगा कि दो शब्द आशीर्वचन के बच्चों को कहें। नीतू मिश्रा जी वाइस प्रिंसिपल हैं। नीतू मिश्रा जी।
Yes, sir. Yes, sir.
जी, आप वोट ऑफ थैंक्स दें।
Okay. First of all, thanks to all the students to be the part of this program. And especially, I would like to thank our speakers for sharing the great ideas that will lead to the great scope and for motivating our students. Thanks to all the members and all the speakers, and a special thanks to Abhimanyu Misra sir for providing this opportunity to our students. Thanks to all the members of this family.
थैंक यू सर। मैं पूरे माउंट कार्मेल ग्रुप की ओर से इसरो के वैज्ञानिक रविशंकर जी को धन्यवाद ज्ञापन देता हूँ। रविशंकर जी सर, आप इतना बड़ा शो ऑर्गेनाइज किए माउंट कार्मेल ग्रुप के लिए, आपको पूरे बच्चों के तरफ से, सारे पेरेंट्स की तरफ से कोटि कोटि धन्यवाद। आप इसी तरह माउंट कार्मेल के बच्चों को आशीर्वाद दें। विशाल कहर जी, आपका जो कार्यक्रम था काफी ज्ञानवर्धक था। विशाल कहर जी, इफ यू आर listening me, if you are hearing me, your show was, your presentation was highly knowledgeable, marvelous, and I hope that students have learned lots of things from you, Vishal Kahar ji. So from time to time, give blessing to
So
my
right now we are not just blessing. I don't believe a lot in blessing, but I would be there actively if there is anything related to space that I can help with.
Okay, thank you very much, sir.
It is actually
आज का मीटिंग यहीं पे
it is
खत्म होता
actually
है।
a bit funny. I would like to say something. So it is a bit funny that my faith in God came back from a church which was named by Mount Carmel, Our Lady of Mount Carmel, and now I am here again. So with that, yes, Jai Hind.
Okay. Ravi sir,